Hello students, welcome back. Let us take a look at question number 6 of exercise 13.6, chapter 13. It states that for a closed cylindrical vessel, the capacity is 15.4 liters. So capacity, we have learned that it is the amount of solid, liquid or gas that a container can hold, which is nothing but volume. So the volume is 15.4 liters of a closed cylindrical vessel and height is 1 meter. There is a difference in units, liters and meters. Now let's see what we need to find. We need to find how many square meters of metal sheet would be needed to make it. So first of all, when you're talking about square meters or square units, or let's say meter square or unit square, what are we really talking about? We are talking about surface area. We have learned that before towards the very start of the chapter. When you have anything in square units or unit square, it is referring to the area. And now it's a closed cylindrical vessel that we are talking about. So what we need to find is the total surface area of the cylindrical vessel. So we need to find total surface area is equal to question mark. So how do we find the total surface area? Obviously using the formula for total surface area of cylinder, which is 2 pi r into r plus h. So what are the variables that we have? We have 2, which is a constant, pi, which is a constant. Then we need the radius of the base. The radius is not given, so we will have to find it out, and the height has already been given, h. So how do we find the radius? Using the volume as well as the height. So now we can directly substitute the value of the volume and height into the formula of volume of cylinder, which is pi r square h. But because we have a difference in the units, that's liters and meters, we will first convert the liters somewhere into units of meters and then substitute the formula in the volume to find the radius and then find the total surface area of the closed cylindrical vessel. So let's get started. Now we know that 1 liter is equal to 1000 centimeter cube, and we also know that 1 meter is equal to 100 centimeters, right? So let's first convert 15.4 liters into terms of centimeter cubes. So I'll say liters and I'll say centimeter cube. This is volume, right? So 15.1 liter is equal to 1000 centimeter cubes. Therefore 15.4 liters is, let's say, x centimeter cubes. Therefore x is going to be 15.4 into 1000, which is 154 into 100. This is what? This is the volume in centimeter cube. Now we have 1 meter and 100 centimeters, right? So, and what is this? This is the volume in centimeter cube. That means I need centimeter cube on the left hand side, on my right hand side. So what I'm going to do is I'm going to cube this equation. So what do I get? 1 meter cube is equal to 100 cube centimeter cubes, right? So 1 meter cube is equal to 1, 2, 3, 4, 5, 6 centimeter cubes, right? So we are going to use this equation to find the volume in meter cubes, because here the height is in meters and we also need to find how many square meters of metal sheet. So again, I'm going to say meter cube and centimeter cube. 1 meter cube is equal to 1, 2, 3, 4, 5, 6 centimeter cubes. Therefore 154 into 100 centimeter cubes is, let's say, y. So y into 1, 2, 3, 4, 5, 6 is equal to 154 into 100. Therefore y is going to be equal to 154 into 100 upon 1, 2, 3, 4, 5, 6. So 2 of the zeros will strike off with these 2 zeros. So what are we left with? We are left with 1, 2, 3. 154, and how many places in the denominator for the 0 after 1? 1, 2, 3, 4. So this will be equal to, going backwards towards the left, by 4 decimal places in order to get rid of these 4 zeros in the denominator, we get 0.0154 meter cube. So what do we eventually have? We have the volume in meter cubes. So volume of vessel is equal to 0.0154 meter cubes, right? But this is also equal to volume of cylindrical vessel is equal to pi r square h. Let's mark this as 1 and let's mark this as 2. So from 1 and 2, what do you get? 0.0154 is equal to pi r square h, right? So 0.0154 is equal to 22 upon 7 into r square into h, which is 1 meters, right? 1 meter. Therefore, r square is going to be equal to 0.0154 into 7 upon 22. So what we are going to do is try and get rid of these decimal places out here. So this is going to be equal to 154 upon 1234 into 7 upon 22. Let's cancel. 2 11s are 22, 2 7s are 14, 2 7s are 14, 11 1s are 11, 11 7s are 77. So we are left with r square is equal to 7 into 7 upon 1, 2, 3, 4. Therefore, r is going to be equal to square root of this. When you take square roots on both the side, you get r is equal to square root of this entire fraction, 7 into 7 upon. So instead of these 4 zeros, I can write it as 100 into 100, because 100 into 100 is going to give you 1 and 4 zeros, right? So this is 1, 2, 1, 2. So finally, we are going to take one of the 7 and one of the hundreds out to get the square root. So this is going to be 7 upon 100, which is equal to 0.07. Why 0.07? Because we have 2 zeros in the denominator, so we are going backwards by 2 decimal places towards the left. So your radius is 0.07 meters. Let's mark this as 3. So now we have the radius, we have the height, that is 1 meter. Can we find the total surface area? Yes, we can find the total surface area, which will give us the answer to this question. So how about you go through this entire section, because I am going to erase it to solve the latter part. Okay. So total surface area of cylindrical vessel. So I am just saying Sylv, okay, or rather let me just write it. Cylindrical vessel is equal to 2 pi r into r plus h. We have learnt this earlier, right? So this is going to be equal to 2 into 22 upon 7 into r is 0.07. So instead of 0.07, can I write 7 upon 100? Yes, I can. 7 upon 100, 7 upon 100, and this I will just write as 0.07, depending on how we exactly need to cancel or we need addition. Whenever you need addition, it's better not to have one fraction and the other term as a whole number. And when you need cancellation, try taking the fractions. So here I am just using my judgment. Why am I taking this as 7 upon 100? Because if I take this as 0.07, and I have a 7 out here, right? So it will give me a decimal point. And here I would prefer taking 0.07 plus 1, because here adding 0.07 to 1 would be simpler than doing this 7 upon 100 plus 1. In this case, I would have to take the LCM and then it becomes really tedious. So this will come with practice. Anyway, so 7 ones are 7 ones are. I am left with 2 into 22, which is 44, into 0.07 plus 1 gives me 1.07 upon 100. So now what I'm going to do is, I'm going to split 44 into 40 plus 4. So I will write 1.07 into 40 plus 4 upon 100. So when you do the calculation, you get 0, 4 sevens are 28 and 4 ones are 4. How many decimal places? 1, 2. So 42.8 plus 428 and how many decimal places? 1, 2 upon 100. So what do we have? We have 42.8 and 4.28. Let's add this, 42.8 and 4.28. You get 8074. 47.08 divided by 100. And now you have 2 zeros in the denominator. So we are going to go backwards by 2 decimal places towards the left. This will become 0.4708 meter square, because we are talking about the total surface area of the cylindrical vessel. So I am just writing total surface area, and we can just write the answer over here. It is 0.4708 meter square. So here is the solution, the pending part of the question. We have moved from this side to this side. I hope you followed it. Please take a look. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.